This is a CLT geometry problem. It's got a lot of components, so it's important to draw out what you're seeing and really indicate that on your drawing. So let's see what it reveals to us as we read. Triangle DEF is isosceles with DE equals EF. If DF equals 16 and the perpendicular distance from DF to point E is 1 less than the length of DF, what is the length of EF? Now, in circling and underlining here, I fully recognize that you can't do that on the CLT itself since it's on the computer. Rather, what I'm trying to do is indicate the sorts of things you should be taking down on your scratch paper and making sure you are extracting every bit of information that is in the question. Most of the time, if you miss a question like this, you have either not taken all the information into account or misinterpreted a key piece of information. So we have an isosceles triangle. If you didn't already know that that means two sides are equal, it actually repeats the idea by telling you that DE equals EF. So we'll go ahead and make little notations there that those are the two equal sides in this isosceles triangle. And then we have the DF is equal to 16. So we've got the first couple of elements labeled. Now we need to think about what is this saying perpendicular distance. So perpendicular, the symbol looks like that, right? It creates a right angle. So we want to be thinking about perpendicular distance from DF to point E. So we need to draw a line from DF to point E. It'd be easier to start at the top. To make it perpendicular, it's going to have to go right down the middle of the triangle. Perpendicular, so we know that we have right angles on both sides. That is 1 less than the length of DF. Well, they already told us what DF is. So we know we can now label that 15. If you have correctly drawn and annotated the triangle to this point, like more than half of the battle is done. I find that on this question, students have a hard time even visualizing what's happening. But if you translate each vocabulary word and take each piece part by part, drawing your own figure on your scratch paper, you will likely be able to get there. Now, what is the length of EF? So they want to know, what is this length right here? Well, when we created those right triangles, you want to think about the fact that that gave you something to work with. It's true that DE equals EF, but we can't infer the length of those sides from simply the 16 by itself. Right triangles are a major tool because now we know that the Pythagorean theorem applies. We can do it with either right triangle, but it makes sense to focus really more on this one on the right, because that is where the missing side that they're asking for is located. In order to do that, we need to divide the bottom side into 2, but that perpendicular distance should be dividing it equally in half because it is dividing an isosceles triangle. We now have a side of 8, a side of 15, and we want to know the third side. Here we have the legs. That's A and B, and we want to know the hypotenuse. That is C. We're ready to plug into the formula, except that there is something called a Pythagorean triple that applies here. That occurs when 3 whole numbers satisfy the Pythagorean theorem: 8, 15, 17. The most popular Pythagorean triple is 3, 4, 5 because 3 squared plus 4 squared equals 5 squared. But this is also a relatively well-known one, and the CLT will over and over again construct problems in such a way that Pythagorean triples will help you. You could certainly discover that 8 squared plus 15 squared equals 289, and the square root of 289 is 17. But keep in mind, you don't have a calculator. So you always want to be thinking about, have they given me a better way to figure out the question without the benefit of a calculator? Another way to think about it is that you can think about 8 squared plus 15 squared. Even if you got it as 289, that would probably rule out all the other answers, right? We know that 17 we can discover by Pythagorean theorem is the square root of 289. Well, that means the answer couldn't be the square root of 353. The square root of 801 is way too large. And use your number theory here, your number sense, to say, well, the square root of an odd number, if that's a whole number, it would have to be odd. We're not going to get an even number times itself to all of a sudden become a number like 289. So if you're kind of stuck on the square root of 289 via Pythagorean theorem, you can still get to the answer by using the answers wisely via elimination. Even better, though, if you know your Pythagorean triples like 3, 4, 5, 5, 12, 13, and this good friend right here, 8, 15, 17, you'll be in much better position. So the length of EF must be 17. And we got there by using all of our information, including the answer choices and any possible shortcuts available to us.